This is your lesson on systems of linear inequalities in two variables. It follows the examples from Glencoe 3.3. In example 1, I'm asked to graph two separate sets of systems of inequalities. In my A, I'm given y is greater than negative 2x plus 4. And in my second one, I'm given y is less than or equal to x minus 2. Let's first take a look at the first guy. Y is greater than. When I go to graph this line, which is already in slope-intercept form, it's going to need to create a negative slope, and it's going to have a dashed line. Okay, that's because it does not have or equal to. And then I'm going to shade above the line because it's y is greater than. Okay, so let's actually go to graph him. Get my little line tool going here, and we're going to have to raise him up. We have a y-intercept of positive 4. We're going to give ourselves a slope of down 2 over 1, and this one looks pretty good. Okay, only issue I'm having with this guy is the fact that my lines that I draw cannot be dashed, so I'm going to give myself a little white lines here just to make myself recognize it is a dashed line because he was not or equal to. Okay. All right, now let's take a look at the last one. Y is less than or equal to x minus 2. He's going to have a y-intercept of negative 2 and a positive slope of up 1 over 1. So let's play around with him. Negative 2, up 1 over 1. That looks pretty good to me, nice solid line. All right, now, the tough part. I need to find an area where I'm matching both of my inequalities. So my first one I knew I shaded above the line. My second one, because he's less than, I'm going to shade below his line, okay? So I need to find the area in which I'm below the red line, but still above the line that's blue, okay? Let me get myself a little different color here. Notice, in this region right here, I am on top of the blue line, but I'm still below the red line, satisfying both of my inequalities. All right, we're now looking at example B, where we're given y is greater than x plus 1, and we're given an absolute value inequality where y is less than or equal to 3. Let's first take a look at our first inequality. Y is greater than x plus 1. Once again, I'm going to have a dashed line with a positive slope, and because he's greater than, I'm going to shade above the line here. Just making a little bit of notes, okay? So let's actually go to graph this guy here. All right, now I'm going to create my line. I'm going to have a positive slope. I'm going to have a y-intercept of plus 1. And my slope is up 1 over 1. Create my line, make it a little bit bigger. That looks pretty good. Okay. Only issue I have with this is the fact that I couldn't really show that it's dashed. So once again, I'm just going to erase parts of my line and show that it's dashed. That's a good method for you if you'd like to on your papers. Just erase part of your line. I'm not going to be too picky about it. All right, now this next guy, absolute value. Hopefully you're remembering your properties. Less than absolute values create an and inequality. So our first scenario is where y is less than or equal to 3. And we're also going to satisfy y, and now we do our two cases, so our flipping and our negating. So y is between 3 and negative 3. Okay. Once again, let's create our line. These ones are going to be solid lines at the spot where we're 3 and negative 3. So here's where y is 3 and where y is negative 3. Don't need to make them as large. Okay. They're solid once again because they're or equal to's. Now I need to figure out where my shaded region lies. I need to be between 3 and negative 3, but also on top of the red line because I was shading above. And the only spot that satisfies everything that I just vocalized is this green area right here. All right, on to example 2. Once again, we are solving a systems of inequality by graphing, and I'm given two separate inequalities. I'm going to graph both, okay? My first inequality is where y is greater than 1/2 x plus 1. So I'm going to create a line. I'm going to play around with it, make sure it actually fits the graph. I have a y-intercept of positive 1, and my slope is up 1 over 2. Looks pretty good to me. Only issue I have with this is the fact that, once again, I need to create dashes in my line because it's not or equal to. So quickly erase parts of my line. There we go. All right, so now the next line also has a slope of positive 1/2 x, and he, however, though, has a y-intercept of negative 3. So I'm going to graph his line. y-intercept of -3, up 1 over 2, perfect. And again, we're going to have some dashed lines here going because we're not or equal to. Now let's figure out where the shaded region lies. My red equation is where it's y is greater than. Greater than means shade above. Now y is less than, that means shade below. Notice in this problem we ended up with two separate regions. And when you're solving a system of inequalities, it's essentially like an and problem here. Both must be satisfied. And in this problem, it is impossible for both to be satisfied. So we do not have a solution set, or it's an empty solution set. You'll also hear null set if you read the study tip in your notes. A good giveaway that this was going to happen was the fact that both lines had the exact same slope. So hopefully you're remembering some geometry. It means they're parallel lines. All right, we're now looking at example 3, which is a real-world problem with a system of inequalities. As I've said before, I find it to be very helpful whenever I'm reading actually the information in the problem and kind of circling it and setting it aside, okay? All right, so NASA has these astronauts who need to be at least 5'4", but they can be no more than 5'11". So that's kind of like a height restriction here due to the limited space inside those capsules. The other piece of information I'm given is the fact that their ages are between the age of 21 and 40. We're going to create a system and then we're going to graph it. Easiest one for us to do is going to be our age, okay? Notice that our age is going to be between 21 and 40. So I know him is greater than 21, but he's also going to be less than 40 here, okay? Next piece of information was our height. Our height is also restricted. Notice that it said at least. Now, at least means that I can actually equal the height of 5'4". Notice that 5'4", we're just going to convert it into inches. That way it makes our lives a little bit easier. And 5'4" is actually going to be a total of 64 inches. Now, it does say no more than 5'11". That means I can still be 5'11". I'm nowhere near that height, so I'm just not going to be an astronaut. 5'11", that's going to be 71 inches. So we now have these systems here, and I'm actually going to have to probably adjust my plane a little bit in terms of what my axes are. All right, you're probably noticing that I just labeled a little bit on my graph here, and that's just to quickly help me graph so that you don't have to waste time while I'm figuring out how to type on my iPad. All right, so notice that we are actually able to skip over a few labeled values. Typically, that's why your graph or your textbook shows a little squiggle between the origin and the little 64. Let's see if I can do a little squiggle. Oops, I had the wrong button. Little squiggle. Squiggle here. Okay, that just means we're going to skip a few values. Okay, so I'm just labeling my scale very clearly. Let's first label the age. The age is between 21 and 40. I'm going to go up by tens on each block. So 21, we're going to say he's approximately right here. He is going to be a dashed line, okay? Then 40, he's going to create a line. So 40 is right here. I just need to pull him down a little bit. Perfect, okay? So both of these are going to be dash. Give them little dash marks here. All right, now let's label our height. All right, so our height is between 64 and 71. So I'm going to have a straight up line, and I'm going to put him over here at the 64. And then I'm going to draw another line at the 70 mark. Oops, that moved my spot. And he was supposed to be right here. All right, so here's about 70. Put those back where they belong. 64, 68, and actually 70 was supposed to be over here. All right, so now we're going to have the shaded region between all those things where I'm height between that and age between that, giving me my little shaded region here. Any astronaut or anybody who wants to be an astronaut just has to fall in those tight little restrictions in order to go inside the capsule. All right, we're going to take a look at our last example. We're finding the vertices of the coordinates formed by the three inequalities provided by your textbook. Notice that they're now not giving you things in slope-intercept form, so we're actually going to take a look at each of them individually. And one strategy that our textbook offers is to graph it. And I do agree that it is a strategy to find your vertices, but just like your textbook points out, it won't always give you accurate points, especially if they're not integer values. So our green equation, we're just going to subtract x over onto the other side, giving me my equation. Y is greater than or equal to negative x minus 1. So now it'll be pretty easy just to graph this. He's going to have a downward slope, and he's going to have a y-intercept at negative 1. Negative 1. And here he is. Solid line because he is or equal to. All right, looking at our second one. I'm actually going to decide to move the y onto the right-hand side. So we have x is less than or equal to 6 plus y. And then I'm going to subtract 6. So x minus 6 is less than or equal to y. Okay. This just means the same thing as y is greater than or equal to x minus 6. They are the same, okay? So when we go to graph this line, we're going to have a positive slope and a y-intercept at negative 6. So going down here, so 1, 2, 3, 4, 5, 6. Give myself a little bit of a better slope. And that's not bad. Okay. So now we need to do the third one, and he kind of runs all around here. 12y plus x is less than or equal to 32. So first off, I'm going to subtract the x over here, and then I'm going to divide by 12 onto both sides. So y is less than or equal to. So 32 divided by 12. Let's see. 12 plus 12 is 24. 24 plus 12 is 36. So a number that goes into both of them is 2. So let's play around with that. So 16 over 6 minus x over 12. Well, 16 over 6, that's also going to simplify down. We can cut those numbers both in half to 8 over 3. So we have a very approximate slope on this one, okay? So we're going to have a downward slope of down 1 over 12 units. And we're going to have a y-intercept of 8/3. So 8/3 is approximately 2 and 2/3. So let's see if I can get this here. So 2 and 2/3. It's approximately right here. And he is a downward slope. But he is a really big one. So down 1 over 12. Whoosh. All right, that looks pretty good. Still not in love with my red line here. Oops. Undo. Okay. So the shaded region created by these guys are going to be the spot that's going to satisfy all of our inequalities, okay? So blue line, we're going to be below him because he's less than. Green line, we're going to be above him because he's greater than. And red line, we're also going to be above him. So we're above red and green, but below yellow. It creates this lovely shaded region right here, okay? All right, so I'm going to zoom out because the real purpose of this was to find the vertice coordinates here, okay? So I'm going to put that over there. So sometimes when you're looking at your graph paper, it's really clear to see just where these things cross or where they intersect. Notice that where I just circled, both green and blue intersect. They're going to intersect at the coordinates -4, 3, okay? And just to help me out, this is the intersection of blue and line green, okay? Because I'm going to look for all 3 intersection points, okay? Another spot that is going to be easy for me to see is the intersection of blue and red, because hopefully you're going to have a little bit better graph paper than I do. And you're going to look at the textbook and realize that, okay? So red and blue, they're going to intersect at the coordinate 8, 2. It's going to be noticed if you draw a scale where it's over 2 and up 2, okay? But notice that we have not paired together yet red and green, okay? And this is what your textbook's looking at here. It's not really intersecting at a nice spot, and you can't make assumptions, okay? So we need to find this coordinate right there. And when we're finding these coordinates, we can use any method we want from our 2x2 systems. Because I have red and green both in y-intercept form here, and they're both set equal to y, I can set their equations equal to each other. So x minus 6 is equal to negative x minus 1. Where x minus 6, that's going to be our red equation, and negative x minus 1, that's going to be our green equation. I'm going to add x onto both sides, and I'm going to add the 6 onto both sides. So x plus x is 2x. This went away. This went away. And negative 1 plus 6, that's going to get me 5. Divide by 2. So x is equal to 5 halves. Now we need to plug that back in to find our y coordinate. Now I'm personally figuring that this lovely equation of x minus 6 is going to be equal to y. That's going to be a lot easier to find our y value. So plugging in 5 halves for x minus 6. 6, I'm going to rewrite that in terms with a common denominator. So something divided by 2 equals 6. That's how I like to look at it. And that's going to be 12, okay? And this is going to be equal to y. So 5 over 2 minus 12 over 2, well, that's going to be equal to negative 7 over 2. So here is our last coordinate, okay? I would like for you to go make sure that you can algebraically solve for this spot, especially if you mess up like I did and you didn't adjust your scale. So we didn't exactly get to see the spot where they intersected. We had to rely upon what the textbook said. One last remark I would like to make is the fact that these vertices in this particular problem, they're the intersection points of 3 inequalities that are all or equal to's. In this scenario, this means that the vertices are also possible solutions. They're contained in your solution set, okay? I want you to think about the other examples we did in this unit so far, where we had inequalities that were not or equal to's. Would their intersection points be solutions? Think about it.